And welcome back. We're on 3.5. It's the final episode of season number 3. We're looking at interpreting the discriminant. Ooh, what is that all about? Well, really we're looking now at determining the number of solutions that you're going to have within a quadratic equation. We've already talked about the quadratic equations being x squared, and the maximum number of solutions you can have is a 2. But there are other options, 0 or 1. When is that going to happen? Why is it going to happen? Let's look at that here today. Let's get started. Solve this linear inequality. Ooh, inequalities. Must mean we're going to do some inequality work here. Not equal. We'll work it through just like we would if it was an equation. So we start by subtracting 18 from both sides. Gives us negative 4x less than or equal to negative 18. And then we divide by the negative 4. Oh, but wait. We got an extra rule with inequalities that we don't with equations. Let's put a star there. If you multiply or divide by a negative, you got to flip the sign. That means then we've got x greater than or equal to 9 over 2. Now in the construct your understanding here, I'm not going to go through all of the quadratic formula for each one of these 4, because we did a lot of that work in 3.4. But we do need to point out this. The whole purpose of what this is saying is that sometimes there's going to be no real roots. Sometimes you're going to have 1 real root. Sometimes you're going to have 2. Sometimes rational roots. Different options. When's that going to happen? Let's look at the development of y. You've seen it in the past. Let's look at y now. Let's look at how these 3 equations are related. They look exactly the same, except they have a different c value. So we're going to plug it into our quadratic formula. Let's work it through and see what happens. Okay, so the a and b is the same. So the c is the only thing that's changing. We got 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 5 over the 2. It's already there for us. That gives us 36 minus 20. Oh, that's 16. I can take the square root of 16. That gives me 4. I'm going to add 4. I'm going to subtract 4. 6 plus 4, that's 10 divided by 2 gives me 5. 6 minus 4, 2 divided by 2 gives me 1. I've got 2 different answers. And these 2 numbers are real numbers. So we've got 2, I'll call them distinct, which is really just meaning different, real roots. Now let's look at the second equation. Again, plugging it in, we get still negative 6 squared minus 4 times 1. This time we're going times 9 on the end. We get 36 minus 36. Oh, that's 0. Square root is 0. That's 0. I've got 6 plus 0 and 6 minus 0. 6 plus 0 is 6 divided by 2. That's 3. 6 minus 0, 6 divided by 2. That's 3. Oh, wait a minute. This time, I've got 2 identical real roots. Or we can say I've got 1 answer. They both come to the same thing. Last one with the 13. Again, negative 6 squared minus 4 times 1. This time times 13. And we've got positive 36 minus 52 gives us negative 16. Oh, wait a minute. We can't take the square root of a negative number. These roots are not real. So we have non-real roots. We're going to be looking at next chapter at the graphs of these quadratics. And the roots, they actually transfer directly into our x-intercepts. I've got 2 x-intercepts there. I've got one x-intercept there. I've got no x-intercepts here. Okay, so back onto page 229 of your book there, we're going to look at these options. The first one, x squared minus 2x minus 3. And if we plug that in through the quadratic formula, we can start seeing that we get a radicand that's a perfect square. And just like I showed you, you're going to get two distinct real roots. And now these two real roots, okay, they're two rational roots. This could have been solved by factoring. If you have rational real roots, meaning there was no square root still at the end, then you could have solved it by factoring. Same equation, but changing the c value again into -1. Let's work this one through, see what happens. Notice here that we get a radicand that's not a perfect square, that 8. When we work it through, we still have the square root at the end. This one still has two real roots, but these are irrational roots. And it cannot be solved by factoring in this case. We would have to be using the quadratic formula to solve it, or the completing of the square. And then the last two, again, changing the c value. Now this one, we've got a radicand of 0. If we've got a radicand of 0, we're going to be adding and subtracting the same value. We're just going to get one answer, 1. This is where we have one rational root, or we can say two identical real roots. And then the last one, this is the one where we have a negative radicand. Can't take the square root of the negative number. It's not a real number at that point. So we say we have no real roots then. So if you notice, when we're looking at 1, 2, or no real roots, it always comes down to what's happening underneath that square root, because that's what really determined what was going on. That part that's determining it is going to be called a discriminant, because another word for determinant is discriminates among the types of possible solutions, the 1, 2, or none. So that discriminant that's sitting there underneath the square root sign, we're going to take it in here, and we're going to say, if that's greater than 0, that's going to be a positive. We can take the square root of a positive number, no problem. We're going to get two real roots. If, however, that discriminant is equal to 0, we'd be taking the square root of 0. We're going to have the identical roots, or one real root. And then if it's less than 0, that means we'd be taking the square root of a negative number, no real roots. So this first one was the square root of a positive. The second one was the square root of 0. The third one's the square root of a negative. So when the question asks you, without solving, how many solutions you're going to have, well, that's really talking about what's the discriminant. So we got to figure out what's the value of the discriminant. Well, same as the quadratic formula. That's A, that's B, that's C. It's got to always be equal to 0 before we can start this. So our discriminant, I'll just call it capital D, is equal to B squared minus 4AC. I'm not taking the square root sign with it. I'm just saying, what's the value underneath that square root sign from the quadratic formula? Substitute in, we get negative 6 squared minus 4 times 9 times 1. 36 minus 36. That equals 0. So my discriminant is 0. That means underneath the square root, I would be having square root of 0 there. Oh, I'd be adding 0, subtracting 0. That means we've got either two identical real roots or really one real root. gives us one answer for the quadratic. Now we get a little bit trickier. Determine the value of k that's going to give us no real roots. Oh. In order to have no real roots, that means that the discriminant, looking back on that page there, is less than 0. We're going to be taking the square root of a negative number. Well, let's plug in. We've got A, we've got B, we got C. My A is 2, my B is 7, my C is K. Let's plug it in and solve for K. 7 squared minus 4 times 2 times K, less than 0. We get 49 minus 8K, less than 0. Hey, let's subtract over our 49. Negative 8K is less than negative 49. Now we got to divide by a negative 8. Oh, that's why we did that first question there. Because when we divide by a negative, we got to flip the sign. K is greater than positive 49 over 8 now. That's the values of K to give us no real roots. Part B. Just pick a value of K that meets this criteria. Okay, well, something that's bigger than 49 over 8. Try 7. Let's just use a K of 7. So that means an equation would be 2x squared plus 7x plus 7 equals 0. Done. There's an infinite number of options that you could have used. Okay, so a number is subtracted from its square. Can the difference be negative? Whoa. When they ask those words, can it happen? They're really asking, what about the discriminant? Do you get real roots? That's really how they're asking this. So let's just pick some variables here. Let's use for the number, let's let n equal the number. And we're going to say that the number squared, so a number is subtracted from its square, and then we're going to get some difference. I'll just call it d. Can that d ever be a negative number? Let's find out. Because they're asking, can this happen on something that has a square, meaning quadratic, we're looking at a discriminant question. So the first thing we want to do with any of the discriminant questions is equate it to 0. Here we go. N squared minus n minus d equals 0. Now I have to figure out, can this actually even happen? Will we get even a possibility of real roots? Well, that's where the discriminant question comes in. Can you get real roots on this type of a quadratic? Well, the way you get real roots is when b squared minus 4ac is either greater than 0, meaning a positive number, taking the square root of a positive, or when it's equal to 0, the square root of a negative. That's fine as well. You still get real roots. That's what the greater than or less than is meaning. How many places can we get real roots off of? So our a value here is 1. Our b value is negative 1. Our c value is negative d. And let's fill it in. We got negative 1 squared minus 4 times 1 times negative d greater than or equal to 0. 1 plus 4d greater than or equal to 0. Let's subtract over that 1. So 4d greater than or equal to negative 1. And now I divide by 4. Don't have to flip the sign. Not dividing by a negative. Greater than or equal to negative 1/4. Okay. What this is meaning is that the difference will always be greater than or equal to negative 1/4. No matter what value of n you choose, you're always going to have a difference greater than or equal to negative 1/4. So now the question is, can you get a difference that's negative? Well, if they're telling you right here that it has to be greater than or equal to negative 1/4, yeah, it can be negative. And specifically, where is it going to happen? Well, if we're talking about being negative, that's when d is less than 0. So anywhere's between 0 and negative 1/4 is a possibility. So yeah, it can happen. All right, finish off with your discuss the ideas. Write something down in here. This is where you're going to learn the most, is when you go further and you think and ask yourself, why? What happens if this? Get down to the understanding, not just can I do it, but why am I able to? I especially like this last question, okay? Because this is going to help you out, is how can you use this discriminant information to get a good strategy for solving. All right, good luck with those, and I'll see you in class.